Welcome to this lecture. In this lecture, we shall consider the concept of multiplication in order. Example 4. Now I'm going to write a question here that may look as if it's difficult, but when we begin to break it down again, you will see that it's not actually so. We have 15a12 over x is equal to 1 over 3b6 in base 12. Find x. We saw this question in the beginning of the video, and now we want to solve this question. We are asked to find the value of x. So how do we do that? Now, working with principles again, what do you think the first thing you should do? The first thing you should do here is like you are giving. Okay, now let's come like this. If you are giving a plate of food to eat, and you can see that you have several things on the food, and you have the food is looking complicated. You have salad, you have chicken, you have stew, you have so many things, and it's like you have to eat all that. Now, what do you need somebody to actually come and tell you, okay, start from here, start with the chicken, or start with the stew, or start with the rice, or start with the drink? You are the one to eat the food, so you begin to think and say, okay, where do I start from that will make me to be able to dissolve or dissect, or taking this food, and just enjoy it. You understand? So that's how it is when you have a math question, like a complex food given to you. So you have to begin to think from all the ways you have been eating. You know where to start from. Nobody has to tell you. So from all the questions you have been solving, you should be able to find one way to start a given question. Yes, those things are called principles. When you solve math questions, you solve them with principles or tactics. So when you are given a new question, you can say, oh, I think from what I've been doing so far, I think this is the first thing I have to do. And as long as that step aligns or is in line with the basic mathematics rules for solving questions, you are good to go. Now, when we have this here, you should know that first of all, we have two fractions and equal to each other. So for us to break this down, we have to resolve the fractions, and the way we have learned to resolve fractions is to cross multiply. So you don't have to say, because I'm seeing base 12, then it's not becoming something very, very big and I don't know what to do again. So we cross multiply, and when we do that, we'll be having 15a12 times 3b6 is 12 equals to what? X times 1, because this x will multiply 1 equal to this fraction numerator multiplying the denominator. That's it. That's what we do when we do cross multiplication. That's what we do. And now you can see that whenever you apply a verified method, a verified principle in solving a question, it will always lead you into a simpler form that will lead you to the solution. Now you can see that just doing that is not leading us to we can decide to bring this to the side and take this to the side. It's the same thing. So let's just do that. We'll now be having what? X times 1 gives x equals to 15a12 times 3b6 is 12. Now, automatically, do you need anybody to explain to you again what the question is asking you to do? Now you can see that if you want to find x, they are simply telling you to multiply this by this in base 12, and that will be the answer to x. That will be the value of x. So the question now is, do you know how to multiply in base 12? If you know how to multiply in base 12, then you eat this question and be happy. Good. Now, for us to multiply in base 12, it follows the same principle like what I've been explaining. So we arrange the numbers 15a and then 3b6 all in base 12. Now, first of all, I'll have to say this to help you. For those of you who are new to my lectures in number-based systems, you need this. But those of you who have gone through my previous lecture, you may not need it. Now, whenever we are working in base that is above 10, base that is above decimal, above 10, we use A to mean 10, we use B to mean 11, we use C to mean 12, we use D to mean 13, we use E to mean what? 14, we use F to mean 15. So this is the limit for what you need in your O-level work, at least since you are going to be working with maximum of hexadecimal, that is base 16. And for base 16 you have 0 to 15. So this is what you need. Good. That means whenever you see A, you know that if you have to convert that into digits, you will have 10 there. Wherever you see B, if you have to convert that into digits, you will have 11 there, just like what we have here. Hope that's clear. Good. So using that there, now it becomes a piece of cake, right? So because it's going to take us back now to what we have been doing before in previous examples. Now 15A times 3B6. Again, here becomes the upper part, which must be done in base 10, and here becomes the lower part, which must be done in what? Base 12, because we are working in base 12. Good. So whatever you're writing down in the lower part must be converted to base 12. So we'll begin. Now we have 6 times A. A is 10, right? So we are saying 6 times 10. 6 times 10 will give us 60, and 60 cannot feature in base 12, because in base 12 we have only 0 to 11, and we are talking of 60. So 60 cannot be recorded down. We have to convert 60 to what? Base 12. Converting 60 to base 12, again using the tactics, the shortcut I've taught you, is to simply group 60 in 12s. When you group 60 in 12s, it's like you are saying divide 60 by 12 and let's see how many whole number and how many remainder. So when you do that, when you convert 60 to base 12 by grouping 60 in 12 places, in 12s rather, what you find out that you will be having what? You'll be having 5 remaining 0. You'll be having 5 remaining 0. So that means 60 converted to base 12 is what? 5 and 0. 5 and 0. Okay, again we can't record 5 and 0, so we have to record the one on the right hand side. Remember, we always record the one on the what? Right hand side and carry the one on the left hand side. So we record down 0 and carry what? 5. Then we move to the next one. 6 times 5. So 6 times 5 gives us 30, and plus that 5 gives us 35. So convert 35 to base 12. So when we convert 35 to base 12, that will be giving us, okay, that will be giving us 2 remaining 11. Good. 2 remaining 11, and that's because in 35 we first of all we meet 24, and 24 can be divided by 12 without a remainder to give us 2, and then 35 minus 24 will be what? 11. So we have 2 remaining 11, 2 groups of 12s and 11 standing alone. So to 11. So how can we record this down? We can simply convert this to 2b, because 11 is b. So we'll simply say we have 2b, and then we put down b and carry 2. So we'll put down b and carry 2. So that's how we do it. Now we'll move to 6 times 1. 6 times 1 gives 6, plus that 2 that we carried will be what? 8, and that features in base 12. So we have 8. Hope that's cool. So that's how it goes. The only place where you may be having some, where I don't really expect anyone to have issues with that, if you have understood what I explained very well, vividly, clearly, in the aspect of converting these numbers. We created the multiplication chart. So if you're having issues converting a number like 35 to base 12, if you're having issues with that, just go over again the aspect of the multiplication chart which we created before we started solving these examples, and go over again and try to create some multiplication charts in some numbers. You just create multiplication charts in some number base. You can create in base 12, create in base 11, create in base 10, create in base 9, create in base 7. Just create multiplication charts so that you can practice how to easily convert numbers from one base, which is in base 10, to another base like base 12 or base 7, even without doing division and saying this into this give us 5, carry remainder 5. And you understand, you can do it smartly. That's what I'm training you to do. You can do it smartly. You may just need to punch your calculator once, and then you don't need to write down anything. You have your values to put down. So we'll move on to the next one. That will be what? B. So b times a is the same thing as saying 11 times 10. Of course, 11 times 10 will give us 110, and that can't feature in base 12. So we have to convert 110 to base 12. So again, you simply divide 110 by 12, and let's see how many whole numbers it will give us, how many group of 12s, and then we will subtract the exact number that gave us that group of 12s. We'll subtract it from 110. So let's do that. So on your calculator, just punch 110 over 12, and that will give you that will give you a value of 9.166 and something, just like that, 9.166. Now we're interested in this whole number part, so we want to know what gave us this 9. So what number actually what number did 12 actually go into to give us that 9 whole number? Actually 12 went into 110. 12 went into what? 110, right? But it gave us 9.166. That means inside this 110 there is a particular number that 12 actually went into that gave us this whole number aspect. Then it was the other ones that 12 can no longer go into without a remainder that now give us this fraction. So how do we get that particular number? We'll get that number by saying 9 times 12. That will give us 108. So it was 108 that 12 actually went into to give us 9 perfect groups without a remainder. Good. So how do we get the remainder now? We'll get the remainder now by saying when we remove this 108 from this 110, what will be left? We'll be left with what? 2. 110 minus 108 will give us 2. So it means that when we convert 110 to base 12, it will give us what? It will give us 9 2. To give us 9 2. That is 9 whole numbers remaining 2. So we record with that which is on the right hand side and carry that which is on the left hand side. So that means we'll have 2 here and then we are carrying 9. Good. Now I hope you are getting used to it already. Now we are going to say b times 5, which is 11 times 5, and 11 times 5 will give us what? 55 plus 9. We are carrying 9 plus 9, that will now make it 64. So we are saying 64 now converted to base 12. Remember 12 can go into 60. 12 can actually go into 60 to give us 5, and that means we'll be having 5 because 12 goes into 60 to give us 5, and we are left with what? 4 remaining 4. So the answer is 5 4. So we go ahead and write 4 here, and then we are carrying 5. Then we move on to the next, which is b times 1. 11 times 1 is 11. So plus the 5 that we're carrying, that will make it what? 16. So converting 16 to base 12, that will be 1 and 4. That's easy. That will be 1 and 4. So since that the last on this side, so we're having 1 and 4. So 1 4 4 2. And then we shall be coming over to the third digits which we have here, and we shall create the last level, the last layer of answers using that digit. So 3 times a, and that means 3 times 10. That will give 30. And of course, in base 12 now we don't have 30, so we have to convert 30 to base 12. And of course, in 30, what number do we have in 30 that 12 can go into without a remainder? Of course, that's 24. That's 24, and that will leave us with a remainder of 6. I mean 30 minus 24 gives 6. That's what I mean. So 12 into 24 will give us 2, and 30 minus 24 will give us 6. So we're having two groups of 12 and 6 remaining in 30, right? In 30, so we're having 2 6, and since we're having 2 6, again we record the one on the right hand side and carry the one on the left hand side, and we are recording now under 3. So we are recording 6 here, and we are carrying 2. So we'll move to the next. 3 times 5, that is 15. So converting 15 to base 12, that's easy. That will give us one group of 12 remaining 3. Hope you got that. Yes, that'll be that one group of 12 and 3 left. So okay, sorry, a quick one, I forgot to add these 2 which we carried. So we're adding the 2 to 3 times 5, which is 15. So 2 plus 15 gives 17. So it's actually 17 we have to convert to base 12, and that will give us one group of 12 and not 3 now but 5. So 1 and 5. So again we are recording the 5 and carrying 1. So we have 5 and we have carried 1. Now 3 times 1 gives 3 plus the 1 we carried. So now we shall do the addition, and now we are doing the addition. So we are now working in base 10. Here becomes the upper part, and we now have a new lower part. So whatever we have here now will be the lower part, and it must be in base 12. So we start with the addition. There's nothing here, so we drop it down. It gives us 0, and then we're having b plus 2. B plus 2 is the same thing as saying 11 plus 2, and that gives what? That gives 13. And since we are working base 12, we can't record 13. We have to convert it to its alphabetical equivalent, and remember, whatever we recorded down here have to be in what? Base 12. So base 12, now we have to convert 13 to base 12 because 13 is not permitted to be in base 12. So converting 13 to base 12, again, that will just give us 1 and 1, right? Okay, 13 actually to base 12. So we recording this one on the right hand side and carry the other one. That will give us 1 here, and then we move to the next column, which is this. We have 8 plus 4, that gives 12, and then we add 6 to 12, that gives 18. So we are converting 18 to base 12. That will give us 1 and 6. That'll give us 1 and 6. Okay, remember we had a 1. Let's not always forget to add our number which we carried. So 18 plus 1 gives 9. So we're converting 19, gives 19 rather. We're converting 19 to base 12. So that will be 1 and 7. So we have 1 and 7. So we record 7 and carry 1 again. So we record 7 here, and then we are carrying 1, and then we'll carry that 1 to this place. Maybe we should just always put it beside it so don't forget. Okay, now 1 plus 4 gives 5, and then 5 plus 5 gives 10, and that is allowed. We can put it in this place because 10 is in base 12, but we don't record it as 10. We don't record it as 10. We know 10 as a value, as an equivalent in alphabet to be a, so we put a instead. So don't forget to do that when working in number base above 10. We always replace those values 10, 11, 12, 13, 14, 15 with their alphabetical values, and then we move to the next one. So it entered all at once. We're not carrying anything. That's the beauty of other base higher than base 10. When we have digits that are within 10 to 15, when working hexadecimal, base 16 or base 13, base 12, when you have those digits, you can actually convert some of them to their alphabetical form, and you don't have to carry anything. Now we'll move to this last column. 1 plus 4 gives 5, and put it down because it's permitted, and this gives us our answer in base 12. So our final answer becomes 5A710 base 12. So that gives us the answer for this.